So let's talk about non-Euclidean. Did you guys know that in normal geometry, there's no way parallel lines can ever meet? But in this, they can, either once in an elliptic geometry or infinitely many times in hyperbolics. Yep, you heard this right. Basically, non-Euclidean is any geometry that's not Euclidean. And the men behind these concepts were no other than Janus Bolyai, Nikolai Lobachevsky, and Bernard Riemann. Carl Friedrich Gauss had his idea as early as 1792, but did not publish it, only told it to Farkas, Janus' father, the one who taught him mathematics. Bolyai appeared between 1820 to 1823, but only published his work around 1832, 2 years later than the publication of Lobachevsky. In 1854, Riemann, under the supervision of Gauss in his doctoral dissertation, gave a lecture about spherical geometry, and it was later published in 1868. The introduction of this non-Euclidean geometry arose from Euclid's fifth postulate about parallels in his book entitled The Elements, stating, given a line and a point not on it, exactly one line parallel to the given line can be drawn through the point. Since a postulate must be self-evident, and that particular postulate was deemed not, several attempts happened to tell the fifth apart from the previous one. Then, when those men came into picture, it turned out that it is possible to have a geometry where the fifth postulate is not true. The statements opposing the parallel postulates are, there are either no lines or there are infinitely many lines parallel to the given line. Also, in non-Euclidean, the sum of the interior angles of the triangle is not 180 degrees.
The discovery of non-Euclidean geometry really affected not just mathematics and science, but also philosophy, since, over the years, no one has questioned Euclidean geometry, which was thought to describe physical space. However, with this concept, the general theory of relativity of Albert Einstein came to light and led to the conclusion that we might be really living in a non-Euclidean space, which is a curved space.
Truly, non-Euclidean geometry had so much history behind, but it's a great concept for it opened the possibility of the fourth dimension. Thanks for listening. Let's keep learning and challenging new ideas.